Okay, see Lindelof videos, continuity at a point, and I want to talk about uh, what are the requirements for a function to be considered continuous at a specific point, and they're really simple. So let's look at it. So the requirements, because this is what your professor wants to know. This is what you're going to be tested on the multiple choice portion of the AP exam. The first requirement, one, is that f of c is defined. It's defined. So here's a picture. Say, okay, well, what would that look like if it wasn't defined? Well, it might look like this if it wasn't defined. Let's imagine for a second that this is our Cartesian plane. So here's our Cartesian plane, right? And we have this function that has this behavior. So let's behavior be this behavior, I guess. And what we're saying is that at some place in here, let this value right here be x is equal to c right here. That there's a hole in the function. Well, if there's a hole in the function, then the function is not defined at that place. And we can talk about, a little bit later, we can talk about what causes holes in function. But this function has a hole, so it's undefined. So if this f of c, this is our function f, right? This is f of x. So if this is c, then this hole right here is f of c, f of that value. And f of c is not defined, so our function is not continuous at that point. The other possibility is actually this, that we talk about this, but that the limit as x approaches c of f of x, people say doesn't exist, but usually it's called fails to exist, so fails to exist. So what might that look like? So we're looking at this function, we're saying, okay, is our function continuous at this point? So get another Cartesian plane. So here's this Cartesian plane right here. And we might have a function that does this, that maybe let this be the value c right here. So this thing goes like this here. And then maybe it does, from this value, it does that. We say, okay, well, c is there and not here. So this is the c value. Well, this limit is not defined because remember, so the limit of f of x as x approaches c doesn't exist. Why? Because as we approach c, let's approach c from this side. So as we move this way, from the left-hand side, our height is approaching this spot right here, isn't it? So okay, our height is approaching this one right here. But as we approach from the other side, as we approach this way, so we start here, as we get closer to c, our height is this one. So the limit fails to exist. Remember, a limit has to the height of the function has to approach a specific height. So let's look at the last example of when a function is not continuous at a point. And that one is actually even easier, and that's when, right, because what has to be true is that the limit of f of x as x approaches c has to equal f of c. So when wouldn't that exist? Well, that would be this weird example here. So maybe we take this Cartesian plane and we draw in our function. We say, okay, here's our c value that we're looking at. You say, okay, as I go this way, the function at c, it approaches here. Say, okay, that's good. And then from here, it approaches c. Right? So I look both ways. I'm like, hey, this function is continuous at this point. Say, well, what if I did this? What if I broke this right here, put a little hole here, and said that f of c is this? Well, then that limit fails, doesn't it? Because f of c would be this value right here in yellow, wouldn't it? Would be this value right here in yellow. But the f of c as defined by the function is here. So the limit of f of x as x approaches c doesn't approach f of c. The yellow is f of c, right? So those are the conditions that have to be met for a function to be considered continuous at a point. And we're also going to try to remember that continuity doesn't mean goes on forever. It means that in that space that we're looking for, there are no breaks in the function. There are no breaks. All right? You guys, thanks for watching. If you have any questions or comments, let me know. If you haven't already subscribed, please subscribe. And thanks for everything, obviously.